Hello, my name is Fiona, and I am a certified teacher and a Praxis coach with Study.com. Are you planning to take the Elementary Education Math test? This is test number 5003. This worked solutions set is for the entire Praxis 5003 exam. These practice problems cover the full range of topics that you can expect to see on the exam. Numbers and operations, algebraic thinking, geometry and measurement, data, statistics, and probability. You will have access to a scientific calculator. Let's review the types of questions you may encounter on the exam. Let's get into it. Problem number 1. Which of the following lists multiples of 8? 1, 2, 4, 8, 8, 24, 48, 62, 1, 8, 16, 24, or 8, 16, 56, 72. Multiples of a number are the products of that number by an integer. So in the case of multiples of 8, it has to be 8 times 1. So the lowest one can be 8. 8 times 2 equals 16, etc. So anything with 1 cannot be the correct answer. So we can eliminate both of those. Now we can look closely at this one. So 8 times 3 is 24. 8 times 6 is 48. But 8 times nothing is 62. 8 times 8 is 64. So we can rule that one out. 8 times 1 is 8. 8 times 2 is 16. 8 times 7 is 56. And 8 times 9 is 72. So these are all multiples of 8. Problem number 2. What is 4,159,350.0342 rounded to the thousands place? So let's write that number down. 4,159,350.0342. So let's look at place values first. This is millions, hundred thousands, 10,000s, thousands. And that's what we're looking for. Hundreds, tens, and units. On the right side of the decimal, we have tenths, hundredths, thousandths, and 10,000ths. So we're looking to round to the thousands place. So we look to the right and we ask, is it 5 or greater? And the answer is no. So we change nothing here except put zeros afterwards, and we can drop the decimal. So the answer is 4,159,000. Done. And there's our answer. How did they get this number? That's just the same. No rounding was done. So we can eliminate that. How did they get this number? What was the question? The question to get this number was to round to the thousandths place. Let's write that down. The thousandths place. Then we would look here. To the right is a 2. Is it 5 or greater? No. So it would just be dropped, and that would be our answer. How did they get this number? That would be asking to round to the hundred thousands place. And we'd look to the right. Is that number 5 or greater? And in this case, the answer would be yes. So that means this number has to increase by 1. And we would have 4,200,000. 1,000. But in this case, the answer is 4,159,000. Problem number 3. Which of the following represents 5.329 times 10 to the power of negative 3 written in standard form? So let's begin. 5.329 times 10 to the power of negative 3. That is equal to 5.329 divided by 1,000. So let's get some zeros in front of this. 5.329, and we're going to divide it by 1,000. So we take the decimal, 1 place, 2 place, 3 places. So the decimal goes there. So that is equal to 0.005329. Now, let's take a look. 532.9 is incorrect. 0.05329, that would be times 10 to the power of negative 2. So that is not correct. 0.005329, check. That is the correct answer. And this cannot be equivalent to 5.329 times 10 to the power of 3. So that is not correct. Problem number 4. Kevin and his 4 friends went to a fast food restaurant to have lunch. The total cost of the food purchased was $52.25. If 5 burger meals cost $31, how much do milkshakes cost if he buys one for himself and each of his friends? So we've got 5 people dining together, Kevin and his 4 friends, and it cost a total of $52.25 for their entire meal. Of that, $31 exactly was the cost of the hamburger meals. So we need to subtract that in order to get the total for the 5 milkshakes. 5 minus 0 is 5, 2 minus 0 is 2, 2 minus 1 is 1, and 5 minus 3 is 2. So the total cost for the 5 milkshakes was $21.25. So now we need to divide that number by 5. So 5 goes into 21 4 times. 5 goes into 12 2 times. We need to bring up the decimal. And 5 goes into 25 5 times. So the cost for each individual milkshake is $4.25. So $7.08, no. $3.54, no. $5.31, no. The math has it at $4.25. Problem number 5. Which of the following inequalities matches the graph? So we've got a number here that is equal to 1 or more. So let's just start plugging the values in. We'll start with 1. 2n plus 3 is less than or equal to 5. With 1 plus 3, and that is equal to 5, is less than or equal to 5, and that is correct. So let's try it with another n. 2 plus 3, and that is 4 plus 3 is 7, is less than or equal to 5, and that is not correct. So that can't be the correct answer. Next, we're going to do 2n plus 3 is greater than 5. We can start with 1 again. 2, 1 plus 3, and that is 5, is greater than 5, is not true. So we can cancel that one out too. We're on to 2n plus 3 is greater than or equal to 5. Let's use 1 again. 2 times 1 plus 3, which is 5, is greater than or equal to 5, and that works. Let's try it with another number. Why don't we try 4? 4 plus 3 is greater than or equal to 5. 2 times 4 is 8, plus 3 is 11, is greater than or equal to 5, and that is true. So this is probably the correct one, but let's look at the last one. 2n plus 3 is less than 5. Let's use n equals 1. 2 times 1 plus 3 is again 5, is less than 5, and that's not true. So the correct answer is indeed 2n plus 3 is greater than or equal to 5. Problem number 6. Which of the following ordered pairs could be plotted on the coordinate grid to produce a square? So let's look first at these ordered pairs. They are in this order, x and y. X-axis, y-axis. And we've already been given 3 ordered pairs, 3 points. So we want D to make a perfect square, and that would be here. This would be D. So let's look at the ordered pairs for A. Its x-axis is -1, and its y-axis is 2. B, x is 1, and y is 2. C, x is -1, and y is 0. And for D, x is 1, and y is 0. All right, let's look at each of these. -1 and 0 is not the new coordinate because that was already C. 0 and -1 would be here, so that's not correct. 0 and 1 would be here, so that's not correct. And we know that D is at 1 and 0, and so that is the correct answer. Problem number 7. If this shape was cut diagonally, which of the following shapes would remain? 2 squares, 2 rhombuses, 2 rectangles, or 2 triangles? Let's cut it diagonally. We cut it diagonally and we are left with 2 triangles, 2 right-angled triangles, not 2 squares, 2 rhombuses, or 2 rectangles, but 2 triangles. Problem number 8. Which of the following is the area of the triangle? The area of a triangle is equal to the base times the height over 2. So we've got the base here and the height here. So that is equal to 2.5 times 2.5 over 2. So let's do the top part. 2.5 times 2.5 is equal to 5 times 5 is 25. 5 times 2 is 10 plus 2 is 12. 2 times 5 is 10. 2 times 2 is 4 plus the 1 is 5. So we add those up and we get 6.25 because we've got 2 decimal places there. So that is equal to 6 1/4 over 2. So 6 1/4 over 2. Half of 6 is 3, and half of a quarter is an eighth. So we have our area as 3 1/8 inches squared, which is the very first and the correct answer. Problem number 9. Which of the following is an example of a positive statistical relationship? When x goes down, y goes up. When x stays the same, y stays the same. When x stays the same, y goes down. Or when x goes up, y goes up. A positive statistical relationship between two variables means that as one variable increases, the other variable also increases. So looking at the first option, this describes a negative relationship, not a positive one. In this scenario, the variables move in the opposite directions. So one's going there, one's going there. When x stays the same, y stays the same. This indicates no relationship or a constant relationship where changes in one variable do not affect the other. It does not show a positive or negative trend since there is no change in either variable. When x stays the same, y goes down. This also does not indicate a positive relationship. In this case, y changes while x does not, but the direction of change, y decreasing, does not relate to a positive correlation with x. Lastly, when x goes up, y goes up. This is the correct example of a positive statistical relationship. As x increases, y increases as well, demonstrating that the variables are directly related and move together in the same direction. Therefore, the correct answer is the option where x goes up, y goes up, as it accurately reflects a positive statistical relationship between the variables x and y. Problem number 10. Consider the following set of numbers: 4, 6, 12, 12, and 15. Which of the following would be the correct method to find the mean of this set of numbers? So we're looking for the mean, and this is where the confusion starts because we've got 3 terms that all begin with m, and they tend to be confused with each other. Mean is what we're being asked here, and that is the average. And to find the average, you add up each number in the data set. So in this case, 4 plus 6 plus 12 plus 12 plus 15, and you divide it by the numbers in the data set, which is 5. And that will give us the mean or the average. Mode is the number that occurs most frequently in the data set. In this case, it's 12. And median is the number in the middle. So half the numbers are lower and half the numbers are higher. It's in the middle, median middle. So let's go through our answer choices and see which one fits with this definition. Add the numbers together and divide by 12. No. Add the numbers together and divide by 5. That is correct in this case. So this is our correct answer, but let's look on. Find the number that appears the most times. That is the mode, and that would have been 12 if that was the answer. Multiply the numbers together and divide by 5. It's adding the numbers together, not multiplying them. So average, mean, add the numbers together and divide by, in this case, 5. Problem number 11. A teacher writes a given median on the board as median equals 14. Which of the following sets of numbers would be correct for this median? So in the previous question, we discussed the confusion between mode, median, and mean. Now we're talking specifically about median. And as we saw before, it is the middle number in a set. And that set has to go from least to most. And if it's an odd number, and in this case, each of the sets has 5 numbers, it's going to be the one in the middle. So we are looking for the middle number to be 14. Let's look here. 23, so that's not it. 15, that's not it. 11, that's not it. The last one, 8, 11, 14, 16, and 20. We've got it right there. 14 is the median in this data set. I trust I was able to clarify this full range of topics that you will encounter on the Elementary Education Math exam, Praxis 5003. Please remember to like and subscribe to this channel so that with Study.com's help, you will feel confident and prepared on exam day. Bye for now.